All right, 2.4 circles. Think. So we're gonna talk about the standard form of equation of a circle. We're gonna graph a circle by hand and by using a graphing calculator. And then we're gonna work equations involving circles. Easy enough. All right, so writing a standard form, here is your equation of a circle. Okay, so we have x minus h squared plus y minus k squared equals r squared. X and y are any point around the circle. What's important are your h and your k. That represents the center of your circle. And r represents the radius from the center to any point on the circle. Super. So x minus h squared plus y minus k squared equals r squared. If your circle falls at the origin, so if it falls at the origin, then the standard is just going to be, I didn't mean to put parentheses. It's going to be x squared plus y squared equals r squared if it falls at the origin. Questions so far about just the formula? All right. So again, oh, it's there if you're at the origin, just in case it's on the next one. All right, so a unit circle. So a unit circle, we're going to actually be utilizing a lot more in the spring for the trigonometry portion of this course. But a unit circle just means that your radius is one unit from the origin. Now, it's just unit because we don't know if we're talking about a foot, an inch, a centimeter. It's just a general unit from the origin of whatever you're referring to, okay? And that's why it's called a unit circle. So the radius is always 1. Let's practice. So if we were to write the standard form of the equation of a circle with the radius 6 and the center -2, 5, are we given everything we need in order to write the standard form? Why, yes, we are. We're given our R, we're given our H, and we're given our K. So as long as I have those 3 variables, can I write the standard form? Yep, it's a matter of just plugging those 3 variables in. So first thing we do is substitute the values in. R equals 6, H equals -2, and K equals 5. So we're going to plug that into our equation. And then once we plug into our equation, we're going to simplify. So negative times a negative is a positive. So we end up with x plus squared plus y minus 5 squared equals 36. And that would be the equation of that circle. Seems doable. Questions so far about example number 1? Awesome sauce. All right, so next objective is graphing a circle by hand and by using a graphing utility, okay? So when you're graphing by hand, you're given the equation. From the equation, you're gonna identify your center and your radius. So looking at what we have right now, what is our center and what is our radius? There you go. The center is -1, +1. And what's your radius? 3. You didn't fall for it. Good job. Okay. So when you're using this, you're going to be using the same equation. And then imagine where you're plugging everything in. Okay. So like Bella said, it's not a +1, it's a -1. And that's because the standard equation is x minus your h and y minus your k, okay? So the values are what change, not the equation. And in order to get 9, we would have to have 3 squared. So once you've identified the center and your radius, then you proceed to graph. Okay, so we have our h, we have our k, we have our r, so we're gonna graph. So when we're graphing, the first thing we do is put our center. And then from our center, we follow our radius. So you typically go the number of the units radius north, south, east, and west. So I went 3 units north, puts me here, 3 units east, 3 units south, and 3 units to the west. Once I have those points, I connect them, and wham, bam, thank you, ma'am, I've drawn a circle. All right, so graphing a circle with the calculator, either pay attention or if you have your calculator, choose to follow along. So we have x plus 1 squared plus y minus 1 squared equals 9. And we're gonna graph this in the handy dandy calculadora, okay? So the first thing we're gonna do is subtract our x term. So we're subtracting x plus 1 squared. The second thing we're gonna do is take the square root of both sides. And remember, when you take the square root of something, it's gonna produce a positive and a negative. You see that? See how we put that plus minus? And the last thing we're gonna do is move our constant from the left side. So we're gonna add 1 to both sides. So now we have 1 plus or minus the square root of 9 minus x plus 1 squared. No, you cannot put that in the calculator, okay? But what you're gonna do is you're gonna put in 2 separate equations in the calculator in order for this to work. You're gonna put in 1 plus the square root of 9 minus x plus 1 squared, and you're gonna put in 1 minus the square root, okay? And what that does is it forces the circle to graph them together. It first forces the calculator to graph them together. So let me open my calculator. Come on, Old Faithful. I'm going to go to y equals. I'm going to type in 1 plus the square root of 9 minus parentheses x plus 1 close parentheses squared close the square root. And then I'm going to repeat that. A shortcut to repeating is if you hit second, enter. Wait. Oh, not on the old one. Never mind. If you're on the new one, it works. But if you're on the old one, it does not work. It will not put your second entry unless you solved it. And I didn't solve anything, so it's not going to put it. But so I have to write it again. 1 minus the square root of 9 minus parentheses x plus 1 close parentheses squared close the square root, hit graph, and it'll do a little thinking, and then it'll draw my circle. So it draws the circle. Why does it not connect it? I don't know. Because they're 2 separate. And it does a little weird thing, but that's as close as a circle you're gonna be able to graph on the calculator. Huh? It's everyone looks like, see? Yeah. Everyone should look roughly like this guy right here. All right. And then once you've done that, now you're in a position where if you're doing it by the calculator, you can find the intercepts, you can find anything that you may be looking for. So if we're choosing to solve it with the calculator, let me get back to my screen. So if I'm looking for the intercepts on the calculator, that means I'm looking for when y equals 0 and when x equals 0. So for x equals 0, it's easy. You just go here and you can see your intercepts, right? Easy peasy. You click second graph and it'll take you to the table and you can see when x equals 0. Do we all see that? Okay. To find when y equals 0, it's a little different. So to find when y equals 0, that's where we go second, trace, and you see where it says 0. That's how you find when your y equals 0. So you'll click there, and then it'll ask you for your upper bound, and that just means, where's my little guy? I don't even see my little spider. Oh, I'm going up, I bet. Come down, come down. He's coming. He's coming. Come on. There you go. Good guy. So there's my little spider. I'm gonna, no, I went too far. I'm down here. Yeah, let's see. No, it usually works. Sometimes it's a little finicky. It says I didn't change the sign, so it's not letting me do it as close. Oh my gosh, go. Be right there. Come on. Where'd it go? I can clearly see it's at 4, but I need it to be on this graph right there. They keep saying I'm skipping it. Oh, I wasn't on it. That makes sense. There we go. Let's see. Now the difficulty is that if it doesn't change the signs, that this doesn't always work because it's not, you're not going from a positive to a negative, so it doesn't see where the 0 could lie. And so it doesn't always work, but if you get it in the right spot, you see how eventually it tells you where the 0 is. So I just wanted to show you that it will do it for you, but sometimes it's easier to just do it by hand. So if you're doing it by hand to find your intercepts, to find your x-intercept, you're going to plug in 0 for y. To find your y-intercepts, you're going to plug in 0 for x. It's the same thing for all functions, no matter, last year we focused on linear and quadratics, right? And then the other ones, it's the same no matter what function it is. That's how you're going to find your intercepts, by plugging in zeros. So we're going to find our x-intercepts by plugging in y equals 0. So you plug in y equals 0, and then we just go through the process to get x by itself. Notice by doing it by hand, I can find my exact value, whereas by calculator, it's giving me an approximate value. So unless it's asking you for an approximate 0 or an approximate y-intercept, then you are expected to complete it by hand. Does that make sense? Okay, so when we go through the steps of solving, notice how we plugged in 0 for y. We then went ahead and simplified this down to 1 because -1 squared is 1. Then we subtracted 1 from both sides. And that left us with 9, with 8. And then we took the square root of 8. Remember, when you take the square root of 8, it equals the square root of 4 times the square root of 2. So that's 2 square root of 2, which is how we ended up with x plus 1 equals 2 square root of 2. So we took the square root. We simplified the square root, and then we subtracted 1 to finish isolating our x. Yes.
It says like -1.8. I got -3.8.
What do you mean?
Like on my graph, it shows for my zeros,
Mhm.
instead of like negative 1.8 and 2.8, it's negative 3.8. It's flipped or something. Like my circle.
It shouldn't be. I mean, you can see where they are. It doesn't really matter which order you get them in. Oh, no. See? Wow. Like you should be fine. All right. So again, if it's asking for approximation, then obviously you can use the calculator. But if it's asking for an exact value, you are not using the calculator. Questions about finding the intercept, the x-intercept. All right. So to find your y-intercepts, this time we're plugging in x equals 0 and then following the same steps, right? So we're going to plug in x equals 0. And when we plugged in x equals 0, we end up with 0 plus 1, which is 1 squared, which is 1. We end up subtracting 1 again, which gives us 8. We end up taking the square root, which gives us plus or minus 2 square root of 2. And then we end up adding 1 in the end, and we get 1 plus or minus 2 square root of 2. So there are 2 y-intercepts. And they are the opposite of what our x-intercepts were. Is that going to always happen? No. Well, depending, it might, where they lie, if it's at the origin, or if it's close, if it's on like a 1, 1, 2, 2, 3, 3 type of situation. If your values of your center are the same, that's the word I'm looking for. All right, questions, comments, or concerns? Okay, so when I put it all together, I now have approximate values. I have a better of a sketch because I have my 4 corners is what I like to call them, my north, south, east, west. And then on top of that, I then have my approximate x and y intercepts. Okay, the more points you have on the circle, the more accurate of a circle you're creating, right? Okay. So next we have working with the general form of the equation of a circle. So this is our general form, x squared plus y squared plus ax plus by plus c equals 0. Yes. Yes, you'll get the review tomorrow. Okay. So again, if this is something you can't recall, or should this be something you write down on your note card? Probably so. So again, we have x squared plus y squared plus ax plus by plus c equals 0. So here we have our general equation. It's x squared. I don't know what happened to my x. Got a little mixed up in the equation, but it's x squared minus 6x plus y squared plus 4y plus 4 equals 0. So x squared minus 6x plus y squared plus 4y plus 4 equals 0. In order for us to graph this, we need to know what our h, our k, and our radius is. Does that make sense? So we need our h, our k, and our radius. So what we're going to do, the first step is to group the terms involving x together, group the terms that involve y together, and we're going to move our constant to the other side. Okay, so when we're grouping these two together, and we're subtracting 4. Okay, the reason why we're grouping is because we're going to end up using completing the square. Do you remember completing the square? Yes, where we split the middle term, double it, then we split it and square it. So that's the second step. So our next step is to complete the square of each expression. Step number 2, is to complete the square. So again, to complete the square, we take our b term. It's your b divided by 2 and squared, right? So here our b term is 6. 6 divided by 2 is 3. Well, -3, and -3 squared is 9. Yeah. Here, divided by 2. 4 divided by 2 is 2. 2 squared is 4. So that's how we ended up with these values. Okay. Now, what you add to one side, you have to add to the other side. Otherwise, does this equation stay balanced? No. So notice how since I added 9 and 4 to both sides, I had to also add it to the right side. Okay. What completing the square allows me to do is to write this as a binomial pair instead of as a trinomial, as a binomial square instead of as a trinomial. So again, we ended up like this, all pretty. And so how do we get there? Well, half of -6 is -3. Half of +4 is +2. So now we're in our standard form instead of general form. And from standard form, can you tell me what my H, my K, and my R are? Yes. I just wrote what's here. I just wrote it prettier. I wrote 3 squared, -3 squared is 9. And 2 squared is 4. Like what these equal. Okay, so now we know that our H and K are 3 and -2. And our radius is 3. Questions about going from general to standard? Okay, now that we have what we need, we have our center and our radius. Can we freely graph this? Why, yes, we can. So I put in my origin, not my origin, my center. I go my north, my south, my east, my west. If the problem asks for further values, I then could also go ahead and find my intercepts. My y is already given to me. It's kind of easy. But... All right. So if I was to use it in the calculator, remember the steps for putting in the calculator is your goal is to isolate the y. So you're doing everything to get y by itself. And then once y is by itself, you're going to put the two separate equations in. And again, they're not going to connect. Right here, it's going to look very close to connection. And the reason being is because they both are at 0, -2. Hi, EP. Okay. Now, what if you're starting here? You do not know the radius, but it's telling you that its center is at 1, -2, and the graph for -2 is part of it. What would you be finding for this equation? What would the radius be? I know the center and I know a point on the circle. So what is that called? What are you calculating? Distance. So this problem, you have your H and your K already. All you're looking for is your radius, which in this case would be the distance. And is there a distance formula that can be utilized? Why, yes, there is. Okay. In this situation, we're using the distance formula. So for us, distance equals the radius, which equals your x2 minus your x1 squared plus your y2 minus your y1 squared. Okay, and some teachers' notes, they may write it, they may write it as radius equals the square root of your, what is it? How have I seen it? Is it x1 minus h? Yeah, x1 minus h squared plus y1 minus k squared, or vice versa. But it's just saying that it's your given point minus the values of your center. Does that make sense? They're all the same variation. I just stick to the traditional distance because it works either way. You're just finding the distance between 2 points. Okay, so notice how I plug in my x2, x1. My y2, y1, and I proceed to subtract, and I end up with the square root of 9, which equals 3. So I know that r equals 3. So now I have my h, my k, and my r, and here's my standard form of the equation. Which means that if I wanted to then go to full general form, I would go through and eliminate parentheses by using FOIL and combine like terms and make sure that one side is equal to 0. Does anyone need to see me go completely from standard to general? Yay, nay, are we okay? Feel good using FOIL and then combining like terms. That's all that took place. Cool. All right. And that is circles.